Hello everyone. So in this video, let's look at the questions of statistics and econometrics in the question paper 2020 NTA NET Economics. So a total of 11 questions were asked from the sections of statistics and econometrics in total. Let's see what were the sections the questions were based on. So the sections covered in the question paper were functions, identification, simultaneous equation bias, probability, stationarity, standard deviation. Here two questions were asked from the section of standard deviation, index numbers, correlation, mean and variance, and heteroscedasticity. So most of these sections can be grouped under one heading, and overall a range of questions were asked from here and there. So it was not fixated on any one particular section, it was asked over a range of sections. And the questions were more or less simple and directly from the theory that we had learnt. We had already discussed in the videos that concerned the theories of all these sections. And one manual question was asked in the section of standard deviation regarding the formula of Z statistic, which was not discussed in detail. That the solution to that we will see in this video. Other than that, the questions were more or less direct. Now let's see what each of the questions were and how to solve them. Now moving on to the question. Question 14 was a match the following question. We have match list 1 with list 2. So in list 1 we have linear function, quadratic function, exponential function and power function. Matching with list 2, we have y equal to 3x square plus 2x plus 9, y equal to 5x cube, y equal to 3 e raised to e to the power of 2x, and y equal to 5x plus 3. And we have the following codes. So we need to match list 1 with list 2. So what do? We basically, this is a question based on the power of the equation. Based on the power of the equation, we match it to the respective function. So that is the basic idea in this question. Based on the power of the variables, based on the power on the variables, we infer what kind of equation each of them is. So let's look at the power of the equation. So y equal to 3x square plus 2x plus 9. The power is 2. So we can directly say that it is a quadratic equation. Y equal to 5x cube is nothing but a power function, and y equal to 3 e raised to 2x, it is an exponential function, there is e in it, and y equal to 5x plus 3 is nothing but a linear function. So it is evident directly from the question what is linear function, what is quadratic function, what is power function, and what is exponential function. So matching them, we get option 1 as the answer. So what is option 1? A 4, B 1, C 3 and D 2. So A is 4. What is A? Linear function. Linear function has 4 as the answer. Y equal to 5x plus 3 is a linear function. And B is 1. B, what is B? Quadratic function. B will be 1 because 1 is y equal to 3x square plus 2x plus 9. Now we have C as 3. What is C? C is exponential function. So we are looking for an equation with the term e exponential factor in it. So it is 3. Y is equal to 3 e to the power of 2x. And lastly D is power function, which is 2. So y equal to 5x cube. It is more than the power 2. So it is a power function. So it is y equal to 5x cube. So option 1 is the solution. Moving on to the next question. We have question 21. Based on the order condition, state whether the first equation is identified given the following structural model. So we have y1 is equal to 3y2 minus 3x1 plus x2 plus u1. y2 is equal to y3 plus x3 plus u2. We have y3 is equal to y1 minus y2 minus 2x3 plus u3, where y's are the endogenous variables, x are the predetermined variables, and u are random. So using this, we need to say if the first equation y1 equal to 3y2 minus 3x1 plus x2 plus u1 is identified or not. So we have to use the order condition. So we have a formula for order condition. So we have to see whether it is over identified, under identified, exactly identified, or if the provided information is not sufficient to solve this question. So we employ the order condition k minus k equal to m minus 1, which we are very familiar with the the equation we are very familiar with to find the order condition. So, k minus k is equal to m minus 1. We have already discussed this in the section of simultaneous equation. So, k minus k equal to m minus 1, capital K minus small k is equal to small m minus 1. So, what do you mean by capital K, what is small k, what is m? Using this, how do we say that whether the equation is identified, over identified, or information is not sufficient? How do we infer all these things? So, what is capital K? K is basically the total number of endogenous and exogenous, or say predetermined variables in the system. The total number of endogenous and exogenous variables in the system belongs to capital K. Now, what is small k? The total number of endogenous and exogenous variable in the equation, that is asked. So, what is the particular equation that is in question? In that equation, how many exogenous and how many endogenous variables are there? That is small k. Now, what is small m? The total number of equations in the system is small m. Now, we have the formula capital K minus small k is equal to small m minus 1. Now, looking at capital K, in the system totally how many endogenous and exogenous variables are there? Let us see how many endogenous and exogenous variables are there. So, in this equation, in this model we have y1, y2, y3. Then we have x1, x2, x3. So, there is y1, y2, y3, x1, x2, x3. So, in total there are 6 variables in the total number of variables in the system. So, capital K, total number of endogenous and exogenous or predetermined variables in the system is 6. Moving on to small k. In the particular equation in question, how many endogenous and exogenous variables are there? So, what they have asked is equation number 1. So, let us go back to equation number 1. In equation number 1, we have y1, y2, x1 and x2. So, basically there are 4. So, we got that too. So, small k, capital K is 6, small k is 4. Small m is how many equations are there in the system. Going back again, we have equation number 1, equation number 2, equation number 3. There are 3 equations. Now, we have all the values. Capital K minus k, small k is equal to small m minus 1. 6 minus 4 is equal to small m minus 1, small m, number of equations in the system. 3 minus 1, 6 minus 4 is equal to 2, 3 minus 1 is equal to 2, we get 2 equal to 2, which means the equation is exactly identified. So, based on the formula, based on the values that we have, we give the values to the equation 6 minus 4 is equal to 3 minus 1. So, using that we get 2 equal to 2. So, the equation is exactly identified. So, looking at the options as the answer, we have option 3. So, the solution to this question is 3, exactly identified. Moving on to the next question, we have question 30. Which one of the following response is true as a solution for simultaneous equation bias? The ordinary least square method, the principal component method, two-stage least square method, 2SLS, the full information maximum likelihood method, FIML. Choose the correct option, whether A and B are true, B and C are true, C and D are true, or A and D are true. So, for this we need to just brush up on the fact of what are simultaneous equation models. We already know this, but still. So, basically simultaneous equations models has more than one dependent or endogenous variable, and the endogenous variable in one equation may act as the explanatory variable in another equation. That is the basic idea of simultaneous equation. Thus, the endogenous explanatory variable becomes stochastic and is usually correlated with the disturbance term of the equation in which it appears as an explanatory variable. Now, in that case, because this possibility is there, OLS cannot be applied. Because the variable's nature changes with every equation, the OLS method cannot be applied, because the estimators are non-consistent and they do not converge to their true population values. So, the option of OLS is eliminated. Now, the only two methods that can be employed is either not principal component method, it is either 2SLS method or FIML method, full information maximum likelihood method. So, we have, going back to the question, we have C and D. So, C and D are in option 3. So, we have solution 3 as to this question. We have only 2 tests that can be used when there is a simultaneous equation, 2SLS and FIML. For any 2 equally likely exhaustive and independent events A and B, P of AB will be equal to. This is a well known a priori theorem in probability which we can answer directly by looking at the question. For any 2 equally likely exhaustive and independent events A and B, P of AB will be equal to 0. The probability of A and B for any 2 equally likely exhaustive and independent event will be 0. So, option 1 is the answer. So, question number 42, time series under the condition expectation of xt equal to mu and covariance xt plus k equal to y of k is said to be strictly stationary, non-stationary, weakly stationary or can't be defined. So, which of the following is the solution for this? Or the time series under the condition expectation of xt equal to mu and covariance of so and so comes under which category? So, what do you mean by a stationary stochastic process? Actually, the answer is weakly stationary, but let us see why is it called so and what exactly is the concept of weakly stationary. So, a stochastic process is stationary if its mean and variance are constant over time and the value of the covariance between the 2 time periods depends only on the distance or the gap or lag between the 2 time periods and not the actual time at which the covariance is computed. So, we have discussed in detail about this in the section simultaneous equation model and time series. So, basically for a process to be stationary, for a stochastic process to be stationary, there are 2 conditions. If its mean and covariance are constant over time and the covariance has this condition. Now, in time series literature, a stochastic process that satisfies these 2 conditions, we call them weakly stationary or covariance stationary or second order stationary or wide sense stochastic process. So, that is what we are looking at this question, weakly stationary, because its mean and variance are constant over time and covariance value between 2 time periods depend only on the lag period and not on the actual time at which the covariance is computed. That is why the given time series in the question is called weakly stationary. On the contrary, if it was non-stationary, it would be time variant, and if it was strictly stationary, it would be a stochastic process whose unconditional joint probability distribution does not change when shifted in time. But strictly stationary process has very little application in time series because it is too restrictive. So, the answer for this question would be option 3, weakly stationary. Now, let us look at the next question. Question 51. Given the sample size 400 with the sample mean 99, the population mean 100 and computed value of Z statistic at 2.5, the value of population standard deviation will be 59.17, 123.46, 8 and cannot be determined. So, this is the question I was talking about, to compute the Z statistic. So, we haven't actually done problems of any such kind, we have only looked at the theory. So, let us look at what is the formula to find the Z statistic if sample size, sample mean and population mean is given. Now, the formula would be, when there are multiple samples, Z equal to x minus mu divided by bracket sigma by root n. Now, x is the sample mean, mu is the population mean and sigma is the population standard deviation and n is the sample size. So, actually we have all these values in the question. What was given? Sample size was given, sample mean was given, population mean was given and Z statistic was given. So, let us compute. So, basically Z is equal to x minus mu divided by sigma by root n. Now, we have Z, the value of Z statistic is equal to 2.5, x minus sigma, x minus what was the equation? X minus mu. So, x is 99, population mean is equal to 100, sigma is the standard deviation and 400, that is nothing but the size of the sample. So basically this is sample mean minus population mean. This is actually a modulus value or an absolute value. So even though it is 99 minus 100, we take it as 100 minus 99, which is equal to 1. Now this is the value of Z statistic, and now this is sigma. Sigma by root n, root of 400 sample size would be 20. So we have 2.5 is equal to 1 divided by sigma by 20. So we get sigma is equal to 20 divided by 25. 200 divided by 25, we get 8. So basically the value of Z statistic would be not 59.17 or 123.46. The given information is more than enough to calculate the Z statistic. So 3, option 3, 8 is the solution. Answer 3. Now next we have a question related to index numbers. Which one of the following price index numbers satisfies the factor reversal test? We have Laspeyres price index, Paget price index, Walsh price index and Fisher's price index. So this factor reversal test and time reversal test, that is very predominantly discussed in the concept of index numbers. The index number that satisfies these kind of test is nothing but the Fisher's price index. So option 4 is the answer. Next we move on to a correlation question. Question 62. What type of relationship exists between two variables if all points on the scatter diagram appear to fall on a straight line going upward from left to right? Is it positive correlation? Is it perfect positive correlation? Or is it negative correlation or perfect positive correlation? Now the answer to this would be actually perfect positive correlation, but that equation, that option is repeated. So either 2 or 4 could be the answer. But to understand this better, let's show it graphically. What is perfect positive correlation? What is perfect correlation? What is negative correlation? And what is perfect negative correlation? So looking at the cases of perfect positive correlation, perfect negative correlation, what is positive correlation, what is negative correlation, etc. Let's look at these figures. So this is an example of, this as you can see is positive correlation, this also is positive correlation. So how is it different? So here the values are all around the curve that shows the increasing trend, and this is on the curve. So this is actually an example of perfect positive correlation, which is the answer in the question that we discussed. So this is an example of positive correlation where a change in one variable causes a change in the other variable also, but by the exact same proportion of that change. That is the example of perfect positive correlation. But in the case of positive correlation, if one variable changes, the other variable changes too, but not in the exact same proportion. The points are all around the trend. Now here we have both are negative correlation, but which is perfect, which is not. So this is a negative correlation. The values are all around the decreasing trend, where if the value of one variable increase, the value of the other variable will decrease, but not by the exact ratio. But in this case, this is an example of perfect negative correlation, where if the value of one variable decrease, the other will increase in the exact same proportion. So negative correlation has an inverse relation, positive correlation has a directly proportional relation, but in this case both will increase. If one variable increase, the other will also increase, but in the case of perfect positive correlation, it will be a exact proportional change. But in the case of negative correlation, it is an inversely proportional relation. If one increase, the other will decrease. But in the case of perfect negative correlation, that decrease will be as equal to the increase. Now this is an example of no correlation. Whatever happens to one variable does not affect the other variable. There is no correlation. The value of correlation coefficient is absolutely 0. Question number 75. Again it is a match the following question. We have list 1, the statistic is given, sample mean x bar, sample variance s square, difference of two independent sample means x1 bar minus x2 bar, difference of two independent sample standard deviations s1 minus s2. And for this we have the standard error. Option 1 we have sigma 1 square by 2n1 and sigma 2 square by 2n2. All this is a product and under a square root. Secondly, we have sigma 1 square by n1, sigma 2 square by n2, again a product under square root. Thirdly, we have sigma by root n, and fourth we have sigma square root of 2 by n. So, this is basically a match between the statistic and the standard error. So, it is a direct question, we just have to match the respective statistic to their respective standard error. So, when we look at this question, we can clearly see that from the options, it is actually option 1. So, A3, B4, C2 and D1. Let us see. A3, sample mean x bar. A is given as 3. Sample mean of x bar will be, the standard error of a sample mean is nothing but sigma by square root of n. That is evident. So, sample mean, the square root of sample mean is equal to sigma by root n. Next we look at sample variance. Sample variance, B is 4. So, sample variance is nothing but sigma square root of 2 by n. The standard error of a sample variance, as we have learnt, is sigma square root of 2 by n. Now, difference of two independent sample means, C, which will be 2, option 2. What is option 2? Root of sigma 1 square by n1 into sigma 2 square by n2. And finally, the difference of two independent sample standard deviations S1 minus S2, that would be option 1, root of sigma 1 square by 2n1 into sigma 2 square by 2n2. So, this is basically the match of standard error with respect to their statistic. But we have learned about in detail the sample mean and sample variance, but these we have not discussed as much. So, these are the new topics or new areas that are asked in this question paper, because these are not often asked. This complicated square root formulas are not often asked. Often what they ask is sample mean and sample variance and their standard error. So, it is good to note these two and learn from now on. Now, moving on to the next question. 79. Given sigma as the standard deviation of a given series, and if to each and every observation of the series is added a constant k, then what will be the standard deviation of the new series? So, if sigma is the standard deviation of a given series and to each observation we add a particular constant k, what will be the standard deviation of the new series? So, we know that the standard deviation will not change, it will remain a constant, it will be sigma itself. So, answer would be 3. But let us show this with an example. Now, let us have a look at this series. We have a series that is differentiated by 1, 2, 3 and 4. So, if we take, the question was, what if we have a series and we have a standard deviation sigma, and if to that particular series we add a constant term k to every individual item, what will be the standard deviation of the new series? That was the question. So, we have 1, 2, 3 and 4 as the series, and for this we have standard deviation sigma. So, we know the variance of this is 1, the difference is 1. Now, the question asks that if to each individual item we are adding a constant term k, say for example k is equal to 2. If to each individual series we are adding 2, so 1 plus 2 is 3, 2 plus 2 is 4, 3 plus 2 is 5 and 4 plus 2 is 6. So, we had an initial series, and to each individual item we are adding a constant term k, which in this case is equal to 2. So, we get 3, 4, 5 and 6. Now, if we take the change that is caused, it is 4 minus 3 is 1, 5 minus 4 is 1, 5 minus 6, 6 minus 5 is 1. So, still there is no change. Even if it is sigma and you add a constant term k to the series, still there is no change caused between the individual items. So, the variance of the new series will still be sigma. So, the standard deviation will not change even if to the new series a constant k term is added. Standard deviation will be constant, that is sigma. With this we come to the last question in this question paper asked in this year. So, question 85, if the disturbance term is heteroscedastic, which one of the responses based on the given statement is true? So, if the disturbance term is heteroscedastic, what will happen to the estimates or how will their features vary? OLS estimators are biased. OLS estimators do not have the minimum variance property. Test of significance based on OLS estimates will be inaccurate, and OLS estimators are inconsistent. So, if the disturbance term is heteroscedastic, what will happen to the OLS estimates? They are biased, do not have the minimum variance property. The test of significance based on OLS estimates will be inaccurate, or the OLS estimators are inconsistent. So, what are the? Choose the correct option. So, we have A and B are true, A and C are true, B and C are true, A and D are true. So, what will happen to the OLS estimators when they are heteroscedastic? They will no longer be blue. So, blue is basically best linear unbiased estimator, because they are no longer efficient. They will no longer be blue because they are no longer efficient. The estimators are now heteroscedastic, that is, the variance is not constant. The property of minimum variance won't hold, that is the basic idea of they are no longer efficient. Hence, the regression predictions or the test of significance will be inefficient too. So, the minimum variance property will not hold and the test of significance will hold inefficient too. So, matching that, the OLS estimators do not have the minimum variance property, that is 1. So, option B is there, and the test of significance based on OLS estimates will be inaccurate. So, when the disturbance term is heteroscedastic, we will neither have the minimum variance property nor we can conduct the test that we conduct in a homoscedastic situation. So, B and C is true when disturbance term is heteroscedastic. So, we have option 3 as the solution. So, with this we have discussed all the questions in the NTA 2020 NET Economics question paper from the sections Statistics and Econometrics. So, as we saw, most of the questions were from the theory that we had already discussed in our videos, and any further specification is discussed in this video. So, hope you all understood it. Thank you.